Hello everyone, welcome back to my YouTube channel. So in this video we will be solving few numericals related to the water treatment topic, and the subtopic of water treatment will be chlorination. This is a very important topic from GATE examination point of view, and when you look at the previous year papers of GATE and especially environmental engineering topic, then chlorination has been asked in bulk quantity, and I have selected few questions. Those are the toughest and that will cover the complete numerical portion of the chlorination. So without any delay, let's get started. So the first question says that chlorine gas 8 mg as Cl2 was added to drinking water sample if the free chlorine residual and pH are measured to be 2 mg per liter as Cl2 and 7.5 respectively. What is the concentration of residual OCl negative ions, and atomic weight of chlorine is given, and the reaction is given as OCl negative plus H positive, and it gets broken into HOCl, and the K for the reaction is given as 10 to the power 7.5. Also you are given with HOCl plus OCl negative. You all might be knowing that this is called as free chlorine residual, and this is given as 2 mg per liter. But this is as Cl2. This is measured as Cl2, and pH is given as 7.5. From the pH, you can easily calculate the concentration of H positive ions. How can you convert? You know pH is equal to log 10 1 upon H positive. Remember that this concentration of H positive ions is always in moles per liter. So whatever the concentration will come from this equation after putting the value of pH, it will be in moles per liter, not in milligram per liter or kilogram per liter. It will be in moles per liter. So put the value of pH as 7.5, and this is log 10 1 upon H positive. So clearly the H positive concentration will be 10 to the power minus 7.5 moles per liter. I hope this much point is clear to you all. Now you know what is K. This K, reaction constant, is equal to the right hand side term of the equation divided by the product of the left hand side term of the equation. This equation can be traced from your basic chemistry of your 12th and 11th standard. So this is equal to 10 to the power 7.5. You know the concentration of H positive, but remember that this equation should be constant. Like if H positive is kept in moles per liter, then OCl negative should be also kept in moles per liter, and HOCl should also be kept in moles per liter. This is the governing rule of this equation, and people get mistaken only at this particular portion in this question. So after substituting the value of H positive as 10 to the power minus 7.5, when you will take this 10 to the power minus 7.5 here, they will cancel out and it will result in 1. That means HOCl concentration divided by OCl minus concentration is equal to 1. That means the concentration of HOCl and the concentration of OCl negative is equal. If this is X moles per liter, then this will also be X moles per liter. Why I am saying moles per liter and not milligram per liter? Because you have substituted H positive in moles per liter. So HOCl and OCl negative should also be kept in the units of moles per liter. Now the concentration of both the ions HOCl and OCl negative is equal to 2 milligram per liter. This is in milligram per liter, but it should be in moles per liter. So how can you convert mass into moles? You know one basic formula. Let me rub this portion. The basic formula is number of moles equals to given mass divided by the molar mass or the molecular mass, we say this. Now you have to find n, number of moles. Per liter will be per liter, but you have to convert this 2 milligram into moles, x moles. So you know given mass is 2 milligram. You know the molar mass, since this mass is as Cl2. So you will have to keep the molar mass of this chlorine gas. That means 2 multiplied by the molar mass of one chlorine atom, and that is equal to 35.5 as per the question. But this is in grams. You all know from your basic chemistry that molecular weight is always in grams. I hope you know, like oxygen, 16 grams. So 2 divided by 2 into 35.5 into 1000. Now this will be in moles, since the denominator and the numerator are in same units of milligram and milligram. So when you will solve this, it will come out to be 2.816 into 10 to the power minus 5 moles. So this is moles, but this is for 1 liter solution, so this is equal to moles per liter. So this is the value of HOCl plus OCl negative. But HOCl and OCl negative are equal in concentration from the equation. From that K equation we finally came to this particular result. So you can write it as 2 into OCl negative equals to 2.816 into 10 to the power minus 5 moles per liter. So when you will take this 2 to the right hand side, you will get the OCl negative concentration as 1.4084 into 10 to the power minus 5 moles per liter. So this is the required answer for this question. I will take up one more question similar to this, but there is some another twist in that question I will take up in the last of the video. So now moving on to the next question. Let me rub this particular part. Now moving on to the next question, and the next question says that an effluent at a flow rate of 2670 meter cube per day, and it has to be disinfected, and the chlorine dosage is given as 15 milligram per liter, and there is one model that relates NT with N0, number of microorganisms at time t in minutes and initial number of microorganisms present. You have to find the disinfection unit volume in meter cube, and it is given that 98% microorganisms are being killed in this particular tank or in this particular operation. So let us solve this. What is the given data? So Q is given as 2670 meter cube per day. When you will convert this in meter cube per second, it is always better to convert the units in standard units, 309 meter cube per second. The model is given as NT equals to N0 e to the power minus 0.145 times T. Remember the very important point here that T is in the units of minute in this particular case. Either you can convert this T into second then and there, or you can later on convert the T that will be coming in minutes to seconds or to days or whatever unit you want. Chlorine dosage is given as 15 milligram per liter, and the percentage kill is 98%. That means in the complete process 98% microorganisms are being killed. But NT here is the microorganisms at the end of the operation. When 98% will get killed, then at the end of the operation there will be only 2% of the microorganisms that will be remaining. So we can write as NT equals to 2% of N0. See, sometimes what happens, this model is not given to you in the question directly. Instead, they say that the value of K is 0.145. Then you should remember this basic model always for such questions where the efficiency is given in terms of percentage, or the percentage kill, percentage survival is given. So you just have to use this model. NT equals to n naught e to the power minus kt. K will be given to you in the question, or the complete model will be given to you in the question. So NT, that means जो microorganisms at the end of operation बच जाते हैं वो केवल 2% है, 98% मर जाते हैं. So this can be written as 0.02 times n naught. Replace this value of NT in this model. So this will be 0.02 n naught equals to n naught e to the power minus 0.145 t. So this n naught and n naught will get cancelled. Now you are left with 0.02 equals to e to the power minus 0.145 t. Now what you can do is, you can see that it is in the base of e exponential. So you can take the natural log on both sides. So e will get cancelled out. So this will be ln 0.02 equals to minus 0.145 t. When you will solve this equation using a calculator, the value of t will come out as 26.979. But what is the unit of this t? Since you have derived this value from this model and t is in minutes in this model, so this t will be in minutes. But you should convert the minutes into seconds. So 1618.768 seconds. Now you have t, you have q. You have to find out the volume. So q equals to volume divided by time. So t will be volume divided by q. V will be q times t. What is q? 0.0309. And what is t? 1618.768. So when you will solve this using a calculator, the volume will come out to be 50.019 and the units will be meter cube. Q is in meter cube per second and time is in seconds. So second and second will get cancelled out and this will be the final answer. This was the question, this was the solution that you were asked to calculate. I hope this is also clear to you all. Now let us move on to the next question, and again a unique type of question has been taken from the topic of chlorination. I am just picking up all the unique questions so that each and every type of question से आप familiar हो जाएं, और अगर इस type का question को भी mold करके आए तो you are in a position to solve that. So the next question says that 16 mld of water is flowing through a 2.5 kilometer long pipe and diameter is given. There is one pipe and the diameter of the pipe is 45 centimeter and the length of the pipe is 2.5 kilometers. So this is a pipe and initially there is a discharge in the pipe and that is Q1. Later on there is a recommendation to increase the discharge to Q2. Initially there was some chlorine application to the complete water that was flowing through the pipe. So there was dosage 1, D1 amount of chlorine was applied in terms of kilogram per day. Okay, later on now since the discharge has increased, so the dosage should also change. I hope so. What do you say? Yes, the dosage will also change and the dosage should increase as the discharge is increasing to achieve the same degree of disinfection. So the dosage should be increased to D2. So what will be the value of this D2? Q1 is given, D1 is given, Q2 is given, dimensions of the pipe are given and you are asked to calculate the value of this dosage. So let us write the data that is given. Q1 is given as 16 mld. mld means million liters per day. That means 16 into 10 to the power 6 liters per day. This is the meaning of mld. Q2 is given as 22 mld. And D1, dosage of chlorine initially when the discharge was Q1, it is given as 32 kilogram per day. You are asked to calculate the value of the dosage when the discharge is increased to Q2. So there is one very good relation that is called as T1 C1 to the power n equals to T2 C to the power n equals to T3 C3 to the power n and so on. Here n is 1 as given in the question. Okay, and n is called as dilution coefficient or dilution ratio sometimes, but it is generally called as dilution coefficient. This dilution coefficient is given as 1 in this particular case. Okay, now using this relation you have to determine the value of this dosage D2. You can see that there are terms T and C and the given terms are Q and D. So how can we interpret this? See, T is the time and C is the concentration, and concentration is always in milligrams per liter or kilogram per liter and so on. Time can be in days, in minutes, in seconds and so on, because this is a kind of ratio. So if you are taking both the time units in minutes, doesn't matter. If you are taking both the CT units in milligram per liter or kilogram per liter, it won't matter at all. So how can we derive time from this particular equation? See, you know volume. Volume is written as area multiplied by length, and discharge is written as volume divided by time. So time can be written as volume divided by discharge. You know the volume, you know the discharge. So T1 can be written as, what is the volume? See, the volume will be same in both the ratios, in this part also, in this part also. So you need not to calculate the actual volume because it will cut out. So we can write it as V divided by 16 mld. Similarly, T2 can be written as V divided by 22 mld. Since the pipe is same, volume will be same. So V divided by 16 and V divided by 22. So this is T1 and T2. You have calculated T1 and T2. You need to calculate C1. How can you calculate C1 now? See, C1 has to be calculated in terms of milligram per liter. You know Q. Q is in liters per day. And you know dosage. Dosage is in kilogram per day. So if you will divide the dosage with the discharge, you will get the units of kilogram per liter, because day and day will cancel out. If you will multiply, you will not get kilogram per day, but you have to divide to get the units of kilogram per liter. So you have to divide this particular dosage D1 with the discharge. Okay, so D1, what is D1? D1 is 32 and Q1 is 16. See, again the units does not matter until and unless it is in grams per liter, milligram per liter, kilogram per liter, it won't matter. So we are not converting it into exactly milligram per liter. So C1 is 32 by 16. I hope you get it. So this equation turns out to be T1 C1 equals to T2 C2, since n equals to 1. What is T1? T1 is V divided by 16. What is C1? C1 is 32 divided by 16. What is T2? T2 is V divided by 22, and C2, what is C2? C2 is D2 divided by Q2. Q2 is 22. So from this equation, V and V gets cancelled out, and when you will solve this, you will get the value of D2 as 60.5, and this has the units of kilogram per day, same as the units of D1. So this is the required answer. I hope you get this point very clear in your mind. Now let us move on to the next question, and that question is similar to the first question that I explained you, but there is one little difference and there is one little trick that will help you to go through a variety. That is why I have taken up that question. So the question says that chlorine gas used for the disinfection, there is a theory written and the equation is written as HOCl. It gets dissociated into H positive and OCl negative. The reaction constant K is given as 2.7 into 10 to the power minus 8, and this is at 20 degrees Celsius. Now the what is given in the question is that the 90% fraction of the HOCl in the free chlorine residual is available at the pH value. You have to calculate the value of pH. pH is not known to you. You have to calculate the value of pH. To calculate the value of pH, it should strike into your mind directly that you have to calculate the value of H positive. From H positive you can calculate pH, you can calculate pOH and whatever you want to calculate. Okay, it is given that 90% of the fraction of free residual chlorine is made up of HOCl. So you can write that equation as 0.9 times of free residual chlorine FRC is equal to HOCl. Okay, now what is free residual chlorine? It is HOCl plus OCl negative. So this is equal to HOCl. So 0.9 OCl negative is equal to 0.1 HOCl. So 9 OCl is equal to HOCl. So we can derive the ratio of OCl negative to the HOCl ratio as 1 by 9. So this ratio will be used now. See how? K is equal to 2.7 into 10 to the power minus 8, and this is equal to H positive and OCl negative. I explained this, how this came in the first numerical only. So from this HOCl to HOCl, this is the ratio that we have calculated here. So H positive divided by 9 will be equal to 2.7 into 10 to the power minus 8. So from this you can calculate the value of H positive as 24.3 into 10 to the power minus 8. Now pH can be calculated as log 10 1 upon H positive. So when you will substitute this value here, you will obtain the value of pH as 6.614. This is the value of pH. Suppose in the question it would have asked you to calculate the value of pOH. Then pOH can be calculated by 14 minus pH. So by subtracting this value from 14, you can obtain the value of pOH. So this is all about the numericals on chlorination, that is a subtopic of water treatment. And I have uploaded many more videos on several more topics of environmental engineering. You can check out those numericals and you can always ask your queries in the comment section. Thank you everyone.